Hello everyone. Welcome to our PLC training. Today is the first class, and I will introduce our WECON PLC. I think many of you have already used our PLC for a long time, so it's very easy to uh, easy today. Today's class is very easy, but it also have some uh, special special use for some registers and some encryption for PLC. So I think you will get some useful information during this class. Okay, so can you hear my voice? Okay, thanks, mate. And let's start for today's training. Today's training, we will start from two topics. The first topic is our PLC introduction, and the second topic is the user registers and the common special relay and the registers. So let's come to the first. The first is the PLC host composition and wiring, product selection, and the encryption. As you know, our PLC name is follow this naming rules. The first part is the series name. It shows the typical model, LX3V or LX5V. Then it starts with the I/O numbers. The first two digits is the input terminal numbers, and the last two digits is about the output digit terminals. M shows the CPU, PLC CPU, and then T and R shows the output type. T means transistors, and R means relay. And then some PLCs have named with 4H or 2H. It means the channels for the high-speed output. But I want to mention one thing. It's about some PLCs just have a name with 4H and 2H. It means default it means 2H, and you can use two terminal Y0 and Y1 to output the high-speed pass, but for the same PLC, you can also use Y2 and Y3 to produce plus. But due to the hardware difference, the output effort cannot be guaranteed above 20,000 Hertz. So if the customers need a higher process frequency, more than 20,000 Hertz, it's still recommended to use the PLC type with 4H channels. Yes, we have already shared the download link for this presentation, and you can join our WeChat or WhatsApp group to get a link. And then the last two is about the power supply and introduction set. The power supply has A type and D type. A means AC power, and D means DC power. And last is shows 1 or 2, and some PLC that doesn't show any numbers at last. It's about instruction set. 1 means LX1S set, series set, and 2 means LX2N series set. It will show different instruction set supports different functions. For example, if this PLC is end as A1, this PLC doesn't support float point calculation. So you need to, it's recommended to use 2, LX2N series set introduction. And this is the PLC host. It will have, we can see here is the input terminal, and this is our output terminal. And in the top left corner here is a series port RS485, and in the bottom left corner there is one S terminal for RS422, and there is also a DIP switch to turn the PLC program running or stop. And there also a micro USB port to connect PC. You can download the PLC program and online monitor with this port. And even you can download the project when the PLC doesn't connect to the power supply. You can also download it just by a USB cable. Here is a 2 BD board slot. Here is number 1 DB1, and this is DB2. Here you can see the state for the input and output for each terminal, and the PLC state, the power LED, run LED, and the BAT LED shows the state of the butter and for the battery. And this error LED blink when the program is wrong, and if it always on, it shows there is something wrong with the PLC's CPU. Okay, let's move on for the pin for the serial port. The first, we can see the S terminal RS422 port. If you want to make the communication cable by yourself, you can refer to this pin table. It shows each pin's signal and dispersion, and just be And just one thing to remember, you cannot use this port and the RS485 port COM1 in the same time. You will have some and here for the some small input and output terminal PLC. It doesn't have two RS485 port like this one. This has two, and the smaller output PLC has just one, and this is COM2. COM1 is still for RS422. Okay, let's move to the wiring. This is the AC power type PLC's connection. First, we need to connect AC power to L and N terminal. And this picture shows the NPN type input connection. So the negative port is connected to SS terminal, and the X terminal is connected to the power supply, the position positive of the power. And this also for the output. This part is for the output. The PLC can also output DC 24 volt. As we can see here, the DC power output. And our PLC for the moment is only support NPN connection output. So we have to connect the COM port to the power supply negative and the Y terminal to the positive supply. And now this is the DC power type, and you can see the power supply of this PLC is from here, the bottom. You can see the bottom, and the output terminal and the input terminal is also the same. Just remember, the output is also only support NPN type connection. Okay, let's move on for the different output and input terminal. First, we focus on the input terminal. You can see there is just one SS terminal for all the X internal. But for the output terminal, it will divide it into 4 parts, in a 4 group. As you can see, the first group is from Y0 to Y3, and the borderline is the boundary of each group. And you can see the first group is COM0, COM1, COM2 with the Y0, Y1, Y2, and Y3. Some PLC just print 3 COM0 here. And the second group is COM3 to Y4 and Y7, and so on. You can see the bound line here. Okay, let's move to the product selection. Here is just about LX5V series, LX5S series, and the LX3V series. The COM PLC is the main PLC ourselves. And you can see this table to show, in general, LX5V is much powerful than LX5S and LX3V. For example, LX5V supports ECAM and interpolation function, but LX3V doesn't support. And the LX3V doesn't have the built-in SNET port, but some LX5V model have the built-in SNET port. If you want to more detailed information about differences between them, you can refer to our product catalog. Okay, let's move on the fourth part for the encryption. Our PLC support to set some password to protect the PLC and our PLC program. There are 4 types to encryption our PLC. The first way is to set a password for upload the program from the PLC. The second type is to set the download password. And the third is to set a clock password, so you cannot change the PLC's clock. And the fourth is the PLC code. Is to set a PLC code and program code. Just when the PLC code is matched to the program code, the program will be downloaded to the PLC or upload from the PLC. So let's see some videos I made before. First, we can see how the upload password set. As you can see, first we connect to our PLC, and we can check there is no password being set. And then we can set a new password, new upload as password, then set. And then we download the program to the PLC. And here, now we want to upload the program. And it shows immediately we need a password to upload. After you enter the correct password, the program will be uploaded. If you want to clean this password, you can also clean this password by this window. Just remember to connect the same PLC. And it shows we clean the PLC's upload password now. So there is no need to upload password after that. Okay, let's move on to the download password. The same PLC project, and we set the download password. Just remember the password format is 8-bit. So you can input 8-digit numbers. After we set this password, if we want to download this project to PLC, we need to enter the download password. And if you want to clean this password, it just like the same as the upload password. Now we move to the clock password. The first we can, if there is no password for clock, PLC clock, we can modify the PLC's time and date very easily. Now we set the clock password. After that, if we want to modify the date or time, it also shows we need to enter the correct password. And the same steps to clean the clock password. So this is the last one, encryption method, PLC code. First, we connect to the PLC. And check the PLC code and the program code doesn't set. First, we set the PLC code, 8-digit numbers or letters. Set successfully. And now we just download, it shows an error. Operation failed. Program code and the PLC code are inconsistent. The PLC code and program code doesn't match because we didn't set the program code. So we check this option to set the program code. It should be the same as the PLC code. And now download successfully. And you can also see if we want to upload the program or in monitor mode, we also need to enter the PLC code. And then we clean the PLC code. And if you just want to encryption the PLC project, you can use this tool, project encrypt tool. So we can set a very easy password and set, and we save. Save this project to the desktop. Then we open this project. Okay, so we need to close. It also shows we need a password to open this project. Okay, this is our first part for today's training. Now we move on to our users registers and the common special relay and registers. First, let me check. Let me show you the device list for LX3V series. LX3V series have the input relay, output relay, and the intermediate relay M, state relay S, and the timer T, count C, and the count include the high-speed counter, and the data register D, and the point P and I for the workflow, and the constant KH shows the value. And for LX5V series device list is also the same, and only the difference is LX5V has the data registers R, and the 3V doesn't have these data registers. And the system special registers is start as SM or SD. First, we check the user's registers. Create bit address. Hello, if you need bit registers, we usually use register array M. Not a bit. Or sorry, currently it's only the bit registers. Only the bit registers available. Let's move on to users registers. For the input and output, as I just referred, the output relay supports NPN and the PNP wiring, but the output relay only supports PNP wiring, and the register signal is identified by the signs such as X0, X1 to X7, and the series number is numbered in octal. So there is no X8 or X9 in the PLC. The same as the output relay, no Y9 or Y8. Then we move to the internal relay and the state relays. And this relay's series number is numbered in decimal systems. So there have X M8, M9. In decimal. So let's move on the timer. For LX3V series, the timer just according to different PLC firmware, 1S or 2N, or model LX3VP or 3VE have different identified. For example, T0 to T31 is for 100 milliseconds, and T3 and T32 to T62 is for 10 milliseconds timer. For the LX5V series, the timer have the different identification. And you can see it, and you can see this picture. I use T0, the 100 milliseconds timer, and the T2050, the 10 milliseconds timer. When I triggered M0, the number changed very fast in T250, but slower than T0. And when I disable the M0, I disable it, the value of T0 will reset because T250 is a accumulative timer, so the value will maintains when the relay state is off. So let's move to the counter. The counter in LX3V divides to 16-bit out counter and 32-bit bidirection counters. You can change the counter of direction by the special registers. And the different PLC set has different registers. And the non-launched area will be changed by the parameter settings, and I will show you later. For the LX5V series PLC, the counter, the C registers just the 17-bit counters. So the value is up to 32,767. And if you want to make a larger counter, you need to use long counters. This is only available in LX5V. A long counter is basis as the same as the counter, but it's a 22-bit registers. So as you can see in the picture, the number is much bigger than 17-bit value. So let's move to the high-speed counter. For the LX3 series PLC, it supports one phase, one direction, and two phase, bi-direction, and the AB phase. Phrase. Sorry, there is something wrong with the PPT. The one phase with the user start and reset is from C2050 235 to 200 C 240, as you can see in this table, this part. And one phrase with assigned start and set from C241 and C245. The two phrases bi-directional is from C247 and C246 and C250. And the AB phrase type is from C251 and C255. For the LX 5V series, the high-speed counter is set by the parameter set. As you can see it here, if you want to enable HSC0, just choose Use and choose the input mode, single phrase or AB phrase input. And it also shows the occupied X terminal. Just remember, the high-speed counter in LX5V series is 32-bit registers. Now we move to the data registers D and R. The length of each register is 16 bits, and if 32-bit instruction is used, the register are it will fold into 32-bit register for use. The lower register is a low bit, as you can see here, the low byte, and the higher address is the high word. For example, if you use move instruction, MOV instruction, it will move D0 to D10. You will just copy D0's value to D10. And if you use demove instruction, for example, demove D0, D10, it will move D0 and D1 value to D10 and D11. And then let me introduce the indexed registers in LX3V. LX3V's the register is V and Z, as you can see in this picture. If I set V5 as 7, the D3 V5 will equal to D10, because 3 at 7 will be 10. So this one actually is the D10. As you can see, I set D10 as 77. So the D20 also 77 because D3V5, the value of D3V5 is 77. And there is K9V5 because V5 is 7. So K9V5 actually is the K16. Wait a minute, as we can see it later. If I trigger the M5, the value of D10 will be 16. The index registers could be used to combination with other registers or values by application instructions. But they could not use combination with the basic instruction and the step labels diagrammer instructions. And the LX5 also have the index registers, but it's not V or Z. It's a D with a square bucket. Let me show you in a video. Index registers. As you can see, I set D20 as 10. So K5 D20, actually the value is 50. And then if I set D5 D20 as 123, the value D15 also have the same value because these two registers actually the same. 5 add 10 is 50. So these two registers have the same value. You can also use in K4 M100 D20 is equal to K4 M110 because M100 D20 is equal to M110. So the value of them are the same as 321. Actually, the D0 is to set the offset address. So if the D0 is 10, the result of M0 D0 is the value of M10. Okay, let's move on to the system's special relays for LX3V. For LX3V, the special registers is from M8000 to M8 to 8255. You can see it in the PLC editor. When we choose this device monitor, and we can see this is the special relay for the PLC and the special registers for the LX3V PLC. For the details, you can refer to our WECON online support center. And for the LX5V series, there is a pre-appendix for the special relays and registers. For example, the clock information and the scan information. There are also some useful registers for the system's high-speed output and input. As you can see, you can set the frequencies, sampling times, and get the current count value. So let's move on for some special use of the device. This special use is only available for LX5V PLC. The first is to use the bits to form the word. As you can see, there is a very special registers K4M0. Actually, it's a registers combines the M0 to M15, the state M, the value of N, the format is KNB. K is a fixed character, and the value of N is from 1 to 8, which means N multiple 4 bits are combined into a word. As you can see, for K4M0 here is the combination of M0 to M15. B means the bit address numbers. Here is M0. And when I move FFF to this registers K4M0, and you can see from M0 to M11 will be set on in the same time. There are also have some videos here. As you can see, if I just set the K4M0 as FF00, the M8 to M15 will be on. I will show you why. If the value FF00, and you can see the bit 0 to bit 7 will be off, will be 0, it means off, and bit 8 to bit 15 will set 1, which means on. It's the same as this video shows. M0 and M7 is off, means 0, and M8 to M50 on means 1. If I set the value is FF, you can see now M0 to M7 will be on, and M8 to M50 will be off. And it will have the relative useful way to use is to take the bit into the word. The format is DB. D is the number of the data device D. Just remember R is not available in this case, and the B is the bit number need to be taken. It's the range is from 0 to F. As you can see, if I set D200 as 8, the D200.7 will be on, because the bit 7, bit 3, when the bit 3 on, the value is 8. You can also see it in this video. If I set the different relay, the value of D200 also changed based on the value. Now the D200 is 2,370. And you can see this video. The bit 1 is on. The bit 6 is on. And then the bit 8 and the bit B. Okay, let's move to the power down retention settings. Some registers doesn't save the value after the PLC power is off. So if you want to make some change, you can modify the PLC parameters to set the retention settings for each registers and relays. For LX3V, it's from the parameters, PLC parameter and device. And for LX5V, it's from device launch. Let me show you a video for this setting. As you can see, I used M300 and D110 here. They are not in the range, not in the latch range. So when I set the state, and power off the PLC, after I power on and connect the PLC again, you can see the value changed of D2 and D100, and the M300 is not on, it's off now. So now we modify the range to make sure these two can be latched. After finish settings, we download the PLC project. You will also download including the project program parameters. And now I set the value of D100. Power of the PLC. And reconnect the PLC. the value maintains. Okay. Above is today's training. I think it's very easy for many users. But I know there are also some someone who have never used our WECON PLCs. So I hope this today's training will be useful to you. And just remember, tomorrow will be another training. The course is the program follow. It will present by Jim in tomorrow at same time. And just remember to signature here with your supervisor as a confirm you join this meeting training. And just remember to join our training group. I will leave a after class exercise to this group, and I hope you can finish it in time. It's a very easy after class exercise. And in this group, we will also share the presentation and some other announcement in this group. So today's training is finished. Do you have any questions? If you have any questions, you can leave your message in these two groups. Just your leader. Just your leader or boss. I think they also have the training log already. Thank you guys. Hope today's training is useful for you. Okay, so if you have any questions, you can leave the message in our group. So I think today's training will be finished. Thank you for you all to participate in this training. Thank you. Goodbye.